Okay, before we get started, I just wanted to remind you that you do have the opportunity to pause these videos, especially with this one because I will be erasing a lot. So if you ever need a pause to look at the colors or look at anything, feel free to use that. Okay, so I have the graphs g of x and h of x, and they're just transformations of f of x. The first one says, write the equation of g of x in the form that guy. So g of x, I'm going to go ahead and highlight it in yellow, just so you know that we're all looking at the same one. Okay, there's my g of x. First thing I want to figure out is what is my a value? In order to do this, I like comparing it back to the parent function, which I graphed in purple, which is just x squared. Okay, so if I pick 2 points, I like to start with my the function that I end with. So I'm going to choose that vertex. In order to get to the next quote-unquote nice point, which is right there, I went over 1 and then down 1. If I go back to my parent function and do the same thing, the vertex, I want to keep that horizontal shift the same, so I'm still going to go to the right one, but now I go up 1. So now I'm able to compare this vertical change. Okay, if I compare, this used to be 1 and now I'm at -1, well, that means I reflected. So I reflected, so my a is going to be -1. Because 1 times -1 gives me 1. So what I'm going to do is I'm going to go ahead and actually shift or reflect my parent function. And I'm going to do that in orange so that you guys can see. Excuse me. When I have a reflection, all that's impacted is my y values. So I used to be at 0. 0 times -1, still 0. My next point was at 1. Well, 1 times -1, I'm going to be at -1. I also had a point at 1, 1, because 1 squared is 1. If I multiply that, I get -1. So now my reflected function looks like this guy. Okay, remember that you have to do that vertical shift or stretch and shrink and reflect before you compare how you moved left and right, horizontal and vertical shift. Okay, so now that I have the reflected, I can compare my two functions. I like to look at the vertex. It used to be there, now it's here. That means is I went up 1. I'm going to just write it here so I have it for later. And then over to the right 2. Right 2. Okay, well if I talk about up, I'm really talking about my k value. And since it's positive, I'm going up. H, I'm going to the right 2. So that's positive. So now I can substitute in my values. -1, x minus 2 squared, because it's a quadratic, plus 1. I can also get rid of this -1. I don't really need that. I could just have a negative. That's the same thing. Okay. I'm going to go ahead and erase so we can start anew. Write an equation for h of x in terms of f of x. So what I'm asking is, what did I do to this guy over here, this orange guy, f of x, to get to my new function, which is h of x? Okay, the first thing we want to do is figure out our a value. I like to start on my ending function. Here's my vertex, 6, 1. In order to get to the next nice point, my next nice point is at 8, -1. That means I went over 2, and then I went down 2. Now I need to compare that to my f of x. Remember, when we're trying to compare, we have to keep that horizontal change the same. So I still have to go 2. Now if I try to match my function, I'm going to follow down. I end up hitting right here. So I went 2 to the right and down 1, 2, 3, 4. Okay, so if I look and I compare, I had -4, now I have -2. What did I do? Well, I multiplied by 1/2. I actually don't have to worry about a reflection because -4 times 1/2 gives me -2. So I don't have to worry about that. Okay, now I'm going to erase those little guys so that we can actually perform that shrink. So I'm going to do this in purple. So remember, when I have that vertical shrink, I'm really talking about my y values. So let's start with my vertex. My vertex used to be at 4. Well, if I take 4 and I multiply it by 1/2, my new y value is 2. So my new vertex is at 0, 2. Okay. Then what's really nice is, here's another point. I like to have 3 points just so I know the general shape. That's 0. Well, if I take 0 times 1/2, I still get 0. Same thing over there. Those x-intercepts always stay. So my new function, shrunk, is that guy. So I'm going to go ahead and erase the orange because I cannot compare that orange, that f of x, right now to my h of x. Now I can talk about, okay, what did I do to get from this guy, this purple, to the green? Well, I went over 1, 2, 3, 4, 5, 6. So I went to the right 6. I'm comparing vertices. And then I went down 1. Okay, so that means my h value had to be 6 because I went to the right. And my k value has to be -1 because I went down. So h of x equals 1/2 f, and then I moved it to the right, so that's -6 minus 1. Okay, now let's say we went backwards. Well, this is kind of nice because we already talked about our a values. So just to remind you, I'm going to erase this guy. In my f of x function, I went over 2 and down 4. In h of x, I went over 2 and down 2. So now we're going from h of x, my green, to f of x. Okay, well, if I think about that, I'm comparing how did I get from -2 to -4. Well, in order to get from -2 to -4, I need to multiply by 2. So my a value is now 2. I'm stretching that. Okay, so I'm going to actually go ahead and stretch so that we can find our horizontal change. And again, I'm going to do that in purple. Okay, so remember, if I haven't said it enough, vertical stretches and shrinks only apply to your y value. So I'm going to start with my vertex, which was at 1. If I take 1 and I multiply it by 2, I'm now going to be at 2. Okay. So like I said before, I like to have those 3 points. So my next point that I want to look at is -1. Well, if I take -1 and I multiply it by 2, I'm now at -2. And then I had this other point, which was also a y value of -1 multiplied by 2. Okay. So now I roughly, very roughly, have this graph. So now I can talk about, okay, what shifts happened. Well, if I look at this vertex to my new vertex, I went over 1, 2, 3, 4, 5, 6. So I went left 6. Then I went up 2. Okay. So then I know f of x equals 2 because of my a value, h, x minus 6, plus 6, sorry, because I went to the left and it's always the opposite, up 2. That's a plus. Okay. Last but not least, domain and range. So I had to copy it, so just we're looking at part D. If I look at g of x, and I'm going to write it up here just because I didn't have enough room with how I screenshotted the picture. G of x is right here. Remember that quadratics are functions and keep going on. So if I look at my domain is going to be all real numbers. There's no limitations to what I can put in. So it's negative infinity to positive infinity. My range, so I want to talk about my smallest y value to my largest y value. Because my arrows are pointing down, that means my y's keep decreasing. So you can't actually tell me my lowest value. So it's negative infinity. If I look for my highest is right here. Remember that range is talking about your y values. So my y value is 1. And because I actually reach that point, it's going to be a bracket. Parentheses are when we approach something. We approach infinity, we never reach it. Then, let's do h of x, which is, let's erase this guy right here. Okay, still continues for my domain, so it's still negative infinity to positive infinity. My range, I want to talk about my smallest y value. Well, these are still pointing down, which means they continue on as the y's decrease. So it's still negative infinity. That's a parenthesis because I don't reach it, I approach it. My highest point is right there, so if I look at my y value, oh, that's also 1. Bracket because I reached. All right, good luck.